Hi guys, it's Mr. Z again, and today we are going to work on section 3-2. This one is solving inequalities using addition and subtraction, and this should be very similar to what we did in chapter 2. All right, we did these in chapter 2 where they had an equal sign in them, but now we're going to have an inequality symbol in them. So instead of an equal sign, we're going to have a less than or greater than, or less than or equal to, or greater than or equal to symbol. To solve these inequalities, we're just going to use the opposite operation. So the first blank we have here says, what is the opposite of addition? Well, the opposite of addition, well, we're going to use subtraction. And then what's the opposite operation of subtraction? We'll fill this blank in with addition. And then don't forget, once we solve these inequalities, we must graph the solutions on the number line like we did in section 3-1. So let's take a look at examples 1, 2, and 3. Let's solve example number 1. Well, the first thing we want to do is we want to get the x all by itself. So then we have to ask ourselves, what is the opposite of adding 12? Well, we would subtract 12 on both sides. And when we do that, these would cancel out and make 0. So all we have on the left-hand side of our inequality is x. And that is going to be less than 20 minus 12 is 8. So our solution to number 1 is x is less than 8. But then don't forget that we have to graph this on the number line. So just like in 3-1, we're just going to put one number on our number line. That's going to be the number 8. And then notice that this one does not have the equal to bar, so this is going to be the open dot. So we're going to make an open dot, and we're going to put the coordinate of that point would be 8. And then again, this inequality is pointing to the left, so we're going to shade to the left. So on our graph, our solutions are all the numbers x that are to the left of 8. Not including the 8 because of the open circle. And that should make sense to you guys since there is a whole bunch of solutions, right? There is a whole bunch of solutions for x. It's any number over here to the left of 8. So any number to the left of 8 on the number line is a solution to this original inequality. And you guys know that there's many, many, many real numbers that are over here in the shaded region to the left of 8. Let's move on to number 2. So in number 2, we're trying to get the d all by itself on the left-hand side of the inequality. So we're trying to get rid of this minus 5. So we're going to use the opposite. The opposite of subtracting 5 is that we're going to add 5. So if we add 5 on the left-hand side of the inequality, we must add 5 on the right-hand side of the inequality. These would cancel out and make 0. So all we have left on the left-hand side of the inequality is d. And we have the inequality symbol is greater than, and negative 7 plus 5, that's negative 2. So there's our solution for our second inequality. And now we have to graph our solution on the number line. So again, the only number we're going to need on our number line is negative 2. And then notice on this one also does not have the equal to bar, so it's going to be the open dot. So we'll make an open dot at negative 2. And then this inequality symbol is pointing to the right. So we're going to shade to the right. On number 2, I also want to check my answer. So to check my answer, I can pick any number in the shaded region over here. So any number to the right of negative 2 on my number line. So maybe we'll pick something like... maybe we'll pick 1. So we're going to pick the number 1. So what we're going to do is we're going to take 1 and we're going to plug it into our original inequality. So I've written the original inequality here for you. And we chose a number out of the shaded region. We could pick any real number to the right of negative 2 on our number line. But we chose 1. All right, so we're going to take 1. And we're going to take that 1 and we're just going to plug it in there for d. We're going to substitute it in. So if we do that, we have 1 minus 5 is greater than negative 7. So then we have 1 minus 5, that would give us negative 4 is greater than negative 7. And that's true. Negative 4 is definitely to the right of negative 7 on the number line. So it is greater than negative 7. So our solution is good. Let's move on to number 3. In number 3, we want to get the n right here all by itself. So we have to do the opposite of subtracting 0.3 or 3/10 from n. So we're going to add 3/10 on both sides. Adding 3/10 on the right-hand side. And I'm going to add 0.3 on the left-hand side. So on the left-hand side of my inequality, I now have 1.2. I bring down my inequality symbol, which was greater than or equal to. And then these cancel out on the right-hand side, so all I have on that side is n. We normally don't like to write our solutions with the variable on the right-hand side. So let's put the n on the left-hand side, and let's put the 1.2 on the right-hand side. But let's make sure now, when I rewrite this with the variable on the left-hand side, you can see that right now, the greater than symbol right here, it's pointing towards the n, all right? So that inequality is pointing towards the n. So when I rewrite it with the variable on the left, I need to make sure that it's still pointing towards the n. So here's our solution for number 3. That is n is less than or equal to 1.2. Now we just have to graph it on the number line. Again, this time we do have the equal to bar, and when we have the equal to bar, that means we're going to have to make a solid dot. And we have to put 1.2 on our number line. So that's the only number we're going to put on there. So we're going to put 1.2. And we need a solid dot. So let's put right here, we'll put a solid dot at 1.2. And again, the important thing is now that I've written the variable on the left-hand side, then the direction of this inequality, this less than or equal to, the direction of that arrowhead or that point tells me which way to shade it. So I'm going to shade to the left. So I'm going to shade this to the left. And there you go. That's all our solutions n that are to the left of 1.2 or that are less than or equal to 1.2. Now, in this case, our solution does include the 1.2 because of the equal to bar and because we have that solid dot right there. To wrap up section 3-2, we've got a couple story problems. So let's take a look at these. Number 4 says Shelly has a gift card. She's used $14 of the original $30. So the most she can spend is $30, okay? She has at most $30. Now, if you remember back from section 3-1, if she has at most $30 to spend, that is going to be a less than or equal to. So right now we know that she has less than or equal to $30 to spend, all right? And then she's already spent 14, plus she has an additional amount that she can spend. We're going to call that G, I guess, for the number of dollars that she has on that gift card still. All right, so that's our inequality. It says that we have to write it, so we've done that, and we got to solve it. And then we got to say, what does our answer mean? So on this one, to solve it, we are going to try to get G by itself on the left-hand side. So we've got a positive 14 there, so we're going to subtract 14 on both sides. These are going to cancel out and make a 0. So then on the left-hand side, we have G all by itself, and then we have that it is less than or equal to 30 minus 14 is 16. So that's our solution right there. And what does that mean? It means that she has less than or equal to $16 left to spend on that gift card. Now let's try number 5. On number 5, this one says that Mrs. Culver wants to buy a bracelet at an auction, and she is willing to bid no more than $550. So what you want to notice right there is it says no more than right there. So I highlighted that in green. And then if you remember back from section 3-1, no more than, if you look that up, it means that that is less than or equal to $550. So right now we know that Mrs. Culver is willing to spend less than or equal to $550. The next part of the problem says, so far, the highest bid is $475. So the current bid for the bracelet is $475 plus whatever Mrs. Culver was willing to bid. We'll call that B for the number of dollars that she is willing to bid in addition to the $475. And don't forget then that it has to be no more than $550. So it's less than or equal to $550. So now if we solve this, we need to get the B all by itself. So we're going to subtract 475 on both sides. And those will cancel out on the left-hand side and make a 0. So now on the left-hand side, we just have B. And then we bring down our inequality symbol, which is a less than or equal to. And 550 minus 475, that's 75. So that's the solution to this inequality. And then what does that mean? Well, it means that Mrs. Culver is willing to bid less than or equal to $75 more than that, that current bid of $475. All right, guys, so on that one, we wrote our inequality and we solved it. So we are done with section 3-2. Thanks for watching, and see you soon.